Hello students, chapter 5 networking devices. Our topic is bridge. In the previous topics we will discussed about some devices like hub, switch, and our hub is a purely hardware device and our switch is a combination of hardware and software. In switch we see we have more hardware but less software part. In, our bridge is very similar to the switch. This one is also working as it is as a switch. This one have like some problems occur during the uh, LAN bridging. That is the main point to discuss this topic, bridge. Let's go for the discussion. And here a bridge connects segments of lanes. Here you see we connected this LAN 1 and LAN 2 by using a bridge. This bridge have two ports. One is port number 1 and second is the port number 2. The same as it is as our switch working, the bridge is also same as it. Switch is operates in two layers. One is physical layer and second is the data link layer. Same as it is, bridge is also operating in both physical layer and data link layer. Due to this both layers we have hardware plus software. Here software is saying means we have some type of intelligence. Intelligence means we have our bridge will take a decision based on the address matching in the frame in which particular port we need to forward the frame for the corresponding reach to the destination. A bridge is very similar to the switch. In switch we see we have a lookup table, and that lookup table have the four main properties. One is a bridge also have the same, we have a lookup table, and same as this switch, this bridge is also having these four main properties. One is the filtering capability, or you can say the filtering decision. Filtering decision here we are discussing means like same as this bridge. If these are our four stations, this is station number 1, this is station number 2, this is station number 3, and this is station number 4, and these are their corresponding MAC addresses, or you can say the physical addresses, and this is the lookup bridge table for the bridge. On the basis of this table, the bridge will forward the frame to the corresponding port or through the port to reach the particular destination. For example, here this particular station becomes the sender and this becomes the destination, and the sender wants to send a frame to this destination on the other side of the LAN, or you can say in the LAN 2. Here we construct a frame. In frame we know first of all we write the destination physical address. The destination physical address I will consider here only the last part of both. Here the physical address of destination is for example 13, the last digit I am taking only, not the complete address, and here the sender is 41 and the data. This is the frame the sender wants to send to the destination. The frame will be released in the LAN 1. All the stations in the LAN 1 see that frame and make the destination physical address match with their own physical address. Because of no one is having the same physical address, all the particular machines or station in the LAN 1 will discard the packet. Finally, the packet will reach at this port number 1 of this bridge. Port number 1 of the bridge. Port number 1 of the bridge accept the frame and make the corresponding destination match in the table. So here this one match, one by one matching is done. So this is a very small table, but actually in the LANs we have a bridge have a long, or you can say a number of entries in the table, like 500 entries, 1000 entries. So we need to do that things. For that we have some algorithm like bridge learning. Some are static, means that we make sometimes we manually make these tables for the bridge. When we add a new station in the LAN, then we will manually update our table, or When we deleted or remove some station from the LAN, we manually need to delete that entry from the table. For that, we have also some updated technology like transparent bridge. We have this type of bridge we have, which are actually learning from the learning or making the table from themselves, means dynamically. When a frame is coming to the bridge will make an entry for the corresponding frame. Again, or in the future, the frame will coming from that port, or they make entry and forward the frame to the corresponding port numbers. So that's we have a different type of bridges. Here this table, in this table, that make an entry matching one by one, and finally an entry with the particular destination physical address will found. And according to this entry, the bridge will forward the frame to the corresponding port number 2, means to the LAN number 2. In the LAN number 2, all the stations received the packet. They will make a match with the given destination address in the frame as well as their own physical addresses. First of all, this frame will receive the packet. This will discard because the destination address will not match. When the frame received this one, this make a match and accept the packet because the destination address given in the frame as well as its own physical address both are matching. This way, our bridge will make the communication possible with the help of physical addresses, or you can say the data link layer addresses. Means decisions are taken on the basis of this table. Decisions are taken on the basis of this lookup table, or you can say the bridge tables. Here we do use some type of intelligence. Some type of intelligence. That's why we are saying our bridges have both hardware as well as the software combinations. Here also we have more hardware but less software. That's why we are saying that bridge is good, having good decision as compared to the layer 1 devices like hub and repeater. Now second point here is same as this. Bridge also have no storing capability. Bridge also not having any storing capability. They just see the packet and header and see the corresponding destination physical address and forward the packet. Only they doing the forwarding task, no storing capability, only forwarding task. Due to this, we can say that no encapsulation and decapsulation. No encapsulation and decapsulation at the bridge. Packet will not be encapsulated, or you can say no MAC address change. No MAC address change in the frame. As it is the frame received by the bridge, same or the original packet is forwarded in the corresponding port numbers. Here you see we can say that our particular bridge is doing some type of collision domain separator but not the broadcast domain separating. Okay, so these are the main points in the bridge we discussed as similar to the switch. But in bridge we find some type of problems that we call that one as the loop problem. That is the loop problem. What is that loop problem? Let's see this one. Sometimes between the two LAN segments or between the number of LAN segments, we add more than one bridge. Like for example, this is our LAN number 1 and this is LAN number 2, having the number of workstations connected to these ones, and we add this bridge number 1 between LAN 1 and LAN 2. So this is fine. If we have only one bridge, this is fine. The bridge will take the corresponding frames from the port 1 and port 2 and forward the frames in the corresponding ports that they can reach to the destination. But sometimes administrators will add more than one bridge between the LANs because the system became more reliable. More reliable means assume that this bridge number 1 will be down, or you can say the fail. That time our communication between the LANs is fail or down. So to make this type of problem solutions, or to make our system or network reliable, the administrator add more than one bridge between the LAN segments. For example, here between the same LAN 1 and LAN 2, we added one more bridge, that is bridge number 2. Bridge number 2. So, but if a bridge added once more, or you can say this redundant bridge makes a problem in the system. What is the problem? Means they create loop in the system, which is very undesirable, because loops can be created only when two or more broadcasting LANs are connected by more than one bridge. How this problem will occur and what are the main solution we need to for this type of problem, let's discuss. First of all, we will discuss about the problem, and after that we will discuss about the solution of that problem. Here, this is a, for example, this is the, we have a LAN number 1 and LAN number 2. Here we have 4 stations A, B, C, D, and between these two LANs we have two bridge number 1 and bridge number 2. Means you can say that we have two LAN systems connected by the two bridges, or you can say the switches. Here, for example, this one is the sender and this is the receiver. Means you can say station A wants to send a frame to station number D. This one makes a frame, destination address D, source address A, and the data. Means created a frame. Now, frame will be released in the LAN number 1. Frame is released in the LAN number 1 from the station A. Now, this one reached here to the bridge number 1. Both bridges have their tables empty. This is the MAC address and this is the corresponding port number. This bridge also have a table. This is the MAC address entry and this is the port. Now frame will reach to the bridge number 1. Frame reach to the bridge number 1. Let's make an entry as the source address is A and the port number 1. Received from the port number 1. Updated the bridge. Both updated the bridge. Same message here. Frame will reach to the bridge number 1. For example, this is port number 1, this is port number 2, this is port number 1 and this is port number 2. And make an entry as this. Both updated their tables based on the source address A and received from the corresponding port number 1, and both forward the frames. They forward this frame and the frame will reach to the LAN number 2. Frame is reached to the LAN number 2. Here you see in the LAN number 2 we have 2 copies of the frame. Now there are 2 copies of the frame on LAN number 2. Okay, so this frame, they have no idea about the destination because they are just in the learning phase. They are just in the learning phase. So let's see next. Now we have this frame is forwarded to this bridge and this frame is forwarded to this bridge. Means the copies out from the left bridge number 1 is received by the right bridge, which does not have any information about the destination address D, and the copy sent by the right bridge B2 will be received by the left bridge B1 and is sent out for the lack of the information of the destination D. Now again the frame will reach to the bridge number 1 and frame is reached to the bridge number B2. This is done. Same as teach, they will update their entry also, because this time the frame is received from which port? Port number 2. They will update their entry. Address is A and from port number 2, address is A and the port number is 2. Address is A and the port number is 2. Updated the entry and then forward the frame to the LAN number 1. Same frame is received from this side also, frame is received by this side also. Again we have 2 copies of frame in the LAN number 1. 2 copies of the frame in the LAN number 1, and their table bridge number 1 and bridge number 2, both the tables are updated, but still they have no information for the destination D. Okay, means you can say The same thing is repeated for the land number 1 also. Land number 1 also same, like in the land number 2 we received the 2 copies, same as it is in the land number 1 also we received the 2 copies. They again forward this one to the bridge 1. We say this particular frame is forwarded to this bridge and this particular frame is forwarded to this bridge. Means this process is continue on and on, because our bridges are also as a repeater and regenerate the frames. So in each iteration there are newly generated fresh copies of the frame, because bridges have the property of both the physical layer as well as the data link layer. Physical layer, they will work as a repeater, regenerate the frame, and from the data link layer features they will see the MAC address and forward the frame to the particular port. But in their table they have no information about the destination D. That's why our frame is revolving in the loop in the land 1 and land 2 through the bridge number 1 and bridge number 2. This is the main loop problem. Here you see this frame will received here, and now this frame is forwarded in the land number 2. Again this bridge is forwarded here, and again this frame is here, then again here, then again here, again here. So this way our frame will be move here and here, means you can say between the loops, if they have no information about the corresponding destination D. This is the loop problem. So we need to see some serious solution for this problem, because due to this one our frame will never be received or never be accepted by the destination, and never be reached to the destination. So for this problem we have a solution called the spanning tree algorithm. Let's see the solution. To solve the looping problem we have spanning tree algorithm. Spanning tree algorithm is saying, means here we will make a loopless topology. Loopless topology means creating a topology in which each land can be reached from any other land through only and only one bridge, or you can say through only and only one path. Okay, there is no loop. Okay, means, and here one important confusion comes to students, means we are changing the topology. No, we are not changing the physical topology of the system, because physical connections are between the cables and the switches and the LANs and the stations. Here we will create a logical topology. That overlays the physical ones. That overlays the physical, means we can say that we will make a topology like that. That topology does not contain any type of loop, or does not contain any graph structure that will not contain any loop, or you can say the open loop or closed loops. So spanning tree algorithm is a graph in which there is no loop. You can if you want to learn more about this one, you can go through the graph theory. Let's see how our spanning tree algorithm will help us to make a loopless bridge LAN. Let's see this example. Here in this example we have 6 LANs: LAN number 1, LAN number 2, LAN number 1, LAN number 2, LAN number 3, LAN number 4, LAN number 5, and LAN number 6, and corresponding host in these LANs. In LAN number 1 we have host number 1 and 2, in LAN 2 we have host number 3, 4, in LAN number 3 host 5 and 6, in LAN number 4 we have 7 and 8, and in LAN number 5 we have 9 and 10, and in LAN number 6 we have host number 11 and 12. And we have 5 corresponding bridges: bridge number 1, bridge number 2, bridge number 3, bridge number 4, and bridge number 5, connecting these LANs, and their corresponding port numbers are mentioned here as with numbers 1, 2, 3, and 4. So let's see how we solve this problem, looping problem here. This is a number of steps problem. The process for finding involves some steps. Let's the step number 1. Step number 1 is saying select a bridge as root bridge which has the smallest ID. Okay. Step number 1 is saying we will choose our root bridge. Here we have 5 bridges: bridge number 1, bridge number 2, bridge number 3, bridge number 4, and bridge number 5. We will choose a root bridge with the lower index or the smallest index, means bridge number 1 is our root bridge. We chooses bridge number 1 as the root bridge. First step is done. Now second step is saying that select a root port for all the bridges except for the root bridge. Means for all the bridges B2, B3, B4, B5, we will select a root bridge, root port which has least cost path. Least cost path is saying here as means we have minimum number of hops, minimum number of links from that bridge to the root bridge. If any tie will occur, we will take the smaller ID part. Now step number 2 is saying, we will choose root ports. Root ports. Root ports means we have corresponding bridges B1, B2, B3, B4 and B5, and the corresponding root ports we will choose them. I will make a table for you guys simplicity. Now let's see how should we choose these things. Now from the bridge number 1 we have both. We need to choose both as the root ports. So both 1 and 2 are the root ports, because from both side of the root bridge the packets are accepted and forwarded. For the bridge number 2, let's count the minimum number of hops. Bridge number 2 will reach is above side. From the above side, from the port number 1 or 2, there is a possibility to reach this port root bridge 1. So from if we follow this path, then this is bridge number 1, port number 1. So this is the path 1. From here, this is number 2, this is number 3, and this is number 4. If we follow the port number 1, then we will reach to the root bridge by following the 4 links. From the port number 2, 1, 2, 3 and 4. From the port number 2 also, it is possible to reach to the root bridge with following 4 hops or 4 links. Means both 1 and 2 have 4 hops. Then we will choose the port with lower index. Then we will choose here with the port number 1. We'll choose the port number 1 as the root port. This is the root port we choose for the bridge number 2. Same as it is, try to choose from yourself for the bridge number 3 and 4 by pausing the video. Try to solve for the port number bridge number C. For the bridge number 3, is it possible to reach to the bridge with port number 3 and 4? With the port number 3 and 4. Port number 3 we will reach through this 1 and 2 by following these two paths. This one and this one. 2. By following bridge number port number 4, we will reach also with the 2 number of links or 2 number of hops. Okay, means there is a tie between 3 and 4. Both are following the 2 links to reach to the root bridge. So we will again choose with the lowest index. And here we will choose 3 as the root port. 3 as the root port for bridge number 3. Try for the bridge number 4. Let's try for the bridge number 4. Bridge number 4, we have possibility to reach the root port by port number 1 and by the port number 2. By port number 1, we have this one link number 2, link number 3 and link number 4. By 4 links, we will reach to the port number 1 of the root bridge by following, and for port number 2, this one link number 2, link number 3 and link number 4. Same as it is in both port number 1 and 2, we will reach with the 4 links. Again there is a tie, we will choose the lowest index. And root bridge port is became the port number 1 is became the root port. Port number 1 became the root port. Okay, so try for bridge number 5. Bridge number 5 we have possibility with port number 2 and 3. Port number 2 we will reach to the root bridge with 2 links. Port number 3 also we will reach to the root bridge with 2 links. So which will choose the lower index, and lower index is the port number 2. Lower index with the port number 2. We will choose root port as the port number 2 for the bridge number 5. So our second step is done. We will choose the root port for all the bridges. Now go for the step number 3. Step number 3 is saying here, for each LAN choose a designated bridge. Means for each LAN we will choose a designated bridge which has least cost path to the root bridge, and if there is a tie will occur, we will the smallest index bridge, and select the port through which we will reach to the root bridge with less number of links or less number of hops as the designated port number for that bridge. Okay, bridge number 1 is already our let's mark these. First of all, this is the port marked here. These are the important ports for our bridge. I mark that all. Mark these one. Okay, these ports are marked and these cables are marked as the important one for this bridge. Now let's go for the next. For the bridge number 5. How should we reach to the root bridge? Will this link 1 and this link 2. Mean if for the LAN number 1, if we choose bridge number 1 as the main, for the LAN number 2 also we will choose bridge number 1 as the designated bridge, because bridge number 1 is the root bridge and connecting both LAN 1 and LAN 2. For the LAN number 3, if we choose bridge number 5, we will reach to the bridge number 5 to the root bridge. Then we will reach to the root bridge from the LAN number 3 by following link number 1, this link 1, this link 2, and this link number 3. Means we have 3 links between the LAN number 3 and between the root bridge 1 if we follow bridge number 5 as the designated bridge for LAN number 3. LAN number 3 is also connected with bridge number 3. Let's see, if we follow the bridge number 3 as the designated bridge, then how many links or how many hops. So link number 1, link number 2, and link number 3. For the LAN number 3 we have both option, bridge number 3 as well as bridge number 5 as the designated bridge. Both are reached to the root bridge 1 by following 3 links. Again there is a tie, then we will go for the lower index bridge. So we will choose bridge number 3 as the designated bridge for the LAN number 3. We'll choose the LAN number 3 designated bridge as the designated bridge. So for bridge number 3, for LAN number 3, step 3, for the LAN 1 and LAN 2, our designated bridge is bridge number 1. For LAN number 3, our designated bridge is bridge number 3. Okay. For LAN number 4 also we will see. For LAN number 4 also we have 2 options, bridge number 3 and bridge number 5. Let's count the both. 1, if we go through LAN number bridge number 3, 2 and 3. Same 3 links we need to follow. If we follow the bridge number 5, then we also again have 1, 2 and 3. 3 link again, means both 3 and 5 are possible candidate for a bridge for the LAN number 4, and again there is a tie, we will go for the lower index. So LAN number 4, our designated bridge is bridge number 3. For LAN number 4, our designated bridge is bridge number 3. For the LAN number 5, we have options both B4 and B5. We have options for both B4 and B5. Let's choose that one. If we go through this link this way, if we go through this way, we have one link, two link, three link, and four links. If we go through this path, one link, two link, three link again, and four link. If we follow this path, then 1, 2, 3, and 4. So bridge number 4 have two ports 1 and 2 that are reachable to the root bridge 1, and both have destination or number of links as 5 5 or 4 4, you can say 5 5 or 4 4, you can say. Then we will choose bridge number 4 as the root bridge or designated bridge for the lane number 4, for the lane number 5, sorry, lane number 5, bridge number 4, because distance is same through all the possible paths between the lane number 5 through by following the possible links. For the bridge number 2 also we have the links with all the directions, and we will choose lane number 6 designated bridge is bridge number 2. Lane number 6 designated bridges. So step number 3 is done. Now go for step number 4. But before that, we chooses only route designated bridge for the lanes. We also need to choose designated port also. So from which port we are reaching to the destination, we will choose that one also. So let's choose for the lane number 3, we will reach through the bridge number 3, and the designated bridge port is this one. So this is the designated path. I marked with the green ink, and here we have designated this port, and here we have designated this port. Okay, and for this path that all are done, so this one is having this is the main path, this is the main path. We chooses the designated bridge also, and we chooses the designated port also. The step number 4 is saying, mark the ports that are part of it, means these are the forwarding ports. Forwarding ports means root port as well as the designated ports. Forwarding port here it's saying is means the root ports plus designated ports which forward a frame that a switch or bridge will receive. And we also mark the ports that are not part of the spanning tree are called the blocking ports. The blocking ports means ports other than root port and designated port. Root port and the designated ports. Okay, means if we will receive these things, we will mark a LAN with bridge having no loops. LAN with bridge having no loops. You see here we chooses. If this mark is visible to you, this one is the bridge number 1, port number 1, and port number 2 as the root port as well as the designated ports. For the bridge number 5, we have root port, port number 2. For this bridge number 3, we have root port, port number 3, and designated port is the port number 1. Designated port is the port number 1. Means for the bridge number 3, port number 2 and port number 4 are the blocking ports. Port number 2 and port number 4 are the blocking ports. Okay. For the LAN number 4, this one is the designated bridge port number. This is the designated port number. Port number 2 is port number 2 is also the designated port for the LAN number 4. For the LAN number 4 means port number 4. This port number 4 is the blocking port. Port number 4 is the blocking port for the bridge number 3. Same as it is for bridge number 5. For bridge number 5, port number 3, port number 4, and port number 1. These all three are the blocking ports. These all three are the blocking ports. For the bridge number 4, we have block port number 1 as the root port number 3 as the designated port. Means this port number 2 is the blocking port. For this one, this port number 1 is the root port and port number 3 is the designated port. Means this port number 2 is again the blocking port. That's why if you send a packet, that will received by the bridge without any loop. Let's see this one. If we remove these parts, or you can say, if we will make a clean diagram of that one, let's see the clean diagram. If we will make a clean diagram of that one, then how this one will be visible to us. Let's make a clean diagram of this one. So we have this lanes, we have 6 lanes. I am drawing this one, lane number 1, this is lane number 2, lane number 3, lane number 4. Same diagram I am making here without the blocking part. Only the forwarding ports we will consider here with our bridge. Here we have bridge number 1, bridge number 5, bridge number 3, bridge number 4 and bridge number 2. Okay, the corresponding ports we will consider port number 1 and the port number 2. Okay, here only the port number 2 is considered. Here we will consider the 3 ports, port number 3, port number 1 and the port number 2. Now here we will consider port number 1 and port number 3, and here we consider the port number 1 and the port number 3. Now you see, this is our LAN, this is a spanning tree, this is our spanning tree. If we will make a diagram of this one, this is look like this way. This one looks like this way. This is bridge number 1 with LAN number 1 connected to bridge number 5 through LAN number 1. This is bridge number 3 connected through the LAN number 2. This one is connected to bridge number 4 and bridge number 2. This one is connected through the LAN number 3 and this is connected through the LAN number 4. And here we have LAN 5 and LAN number 6. With here we have LAN number 6. This one become a tree, and this B1 is the root of this tree. B1 looks like a root of this tree. You see, there is no loop between any two bridges. Every LAN have a corresponding bridge or a designated bridge. Have the designated ports number, having the root ports. And if you transfer any packet, there will frame from one station to another station. There will not getting any type of loop. For example, these are our hops or station. This is 1 and this is H12, and we want to send a frame. This is the frame number 1 frame with having the destination address as H12 and the source address as H1 and the data. This frame will go through this part. This frame will reach here and then pass to here and then pass to here and then come here and then finally reach to this H12. And this one, if this one come here, then again this one come here, there is no loop will occur. A simple path, H1 going to the bridge number 1. Bridge number will 1 will forward this packet through the port number 2 to LAN number 2. Bridge number B3 will receive this packet from a frame from the port number 3 and forward this one through the port number 2 at the LAN number 4. LAN number 4 and between the LAN number 6, bridge number 2 will accept this frame from the port number 1 and forward this to the port number 3, and finally the packet will reach to the H12 destination. Means there is not a bridge problem or not a loop problem will occur here. Spanning tree will make our loop with make our LAN bridging without any loops, because their spanning tree have this property, a graph. This will make a graph which have no loops. So this is finally the spanning tree algorithm to solve the loop problem in our bridge, to solve the loop problems in our bridge. This way we can solve any type of land bridging network for the loops. Okay. Next we will discuss about some of the advantage and disadvantage of the bridge. Advantage of the bridge, you can say that bridge is a collision domain separator. You see if this is a bridge between the two lanes or between the three lanes. For example, this is line number 1, this is line number 2, and this is line number 3. Here you see bridge will forward the packets to the particular links, to the particular lanes. In LAN there is a possibility of collision. In LAN there is a possibility of collision. In LAN there is a possibility of collision. Bridge is not a collision domain area. Our lanes or our cables are the collision domains. So we can say that bridge is a collision domain separator. Collision domain separator. Bridge is not the collision domain area. Collision domain area is now the links or now the LAN cables. Okay, that's the main advantage. Bridge is a collision domain separator. Hub we see in the last topic. Hub is a collision domain, and the collision is possible on the hub also. Same, one more advantage of the bridge is connecting heterogeneous. Connecting heterogeneous means if device A of a link layer switch or link layer bridge can connect devices that are with the different protocols at the physical layers at the different data rates, or you can say different transmission media. Means it can connect the heterogeneous devices. Heterogeneous devices means bridge, if this one is following a different area, or you can say this is a coaxial cable. This is a coaxial cable. This one can be a twisted pair cable. This one can be a twisted pair cable. Here you can use, or here you can use an optical fiber. Optical fiber means here there is no any type of restrictions. Then you can use both type the same cables, or both side the same data rates are need to be followed of the bridge. Anytime, any side, any type of cable, any side type of bandwidth you can allow between the communication between the LANs. So next, one of the main disadvantage here is this is not a broadcast domain separator, not a broadcast domain separator. Even this one have the lookup table and take the decision of forwarding the particular frame, but this is not a broadcast domain separator till now. Okay, this is all about the bridge, and the main topic in the bridge is about the loop problem and spanning tree algorithm. And so many questions are already asked on basis of these two topics, loop problem or spanning tree algorithms.